Okay, so now we have 3 charges and they're all positive. Only now I realize. Probably some psychologist created this problem, tried to be all the time on the positive side. Okay, I'm thinking how much space I might need. So plus, here another plus, and here just below there is another positively charged, positive charge. Now let me label them. Okay, let me grab my notes. So it's Q1 2 nanocoulombs, Q2 4 nanocoulombs. Actually, 2 sig figs given in the problem. It's a 2.0, but I dumped that additional piece of information. Q3 is 2 also nanocoulombs. Okay, so that's the information about the electrical information. Now geometry is this. This distance is this distance is a. Okay, you know what? I will just write number. So it's 3 centimeters, and this distance is 4 centimeters. Okay, and of course these 3 charges create their own electric fields. Of course, as a result, we can pick any point, and we can ask, what about the net, either electric field or electric potential? Now, since we're talking about electric potential, it's a new thing. So, of course, the question is about the electric potential, and the question asks about this particular point. What about the net electric potential at this point? It's basically a rectangle. Not basically, it is a rectangle. Right, with sides 3 and 4. So at this point, after we had that one of the slides, we basically discussed very similar situation. Now we have to, of course, apply principle of superposition, and principle of superposition is a piece of cake now, because we just need to add 3 numbers. Contribution to the net electric potential from the first charge, from the second charge, and from the third charge. And again, we need to know distances from each charges to the point in question. Right? So we need to know this distance r1, then this distance will be r2, and this distance is r3. r1 is 4. Of course, we will have to convert to meters. Don't use centimeters. r2, okay, you need to use Pythagorean theorem in order to find r2, and it's trivial. 3 and 4 is going to give us 5 centimeters. And r3, 3. Right? So let me immediately calculate r3. Of course, it will be, okay, square root of r1 squared plus r2 squared. Of course, it will be 5 centimeters. And which is, of course, we need to convert to meters. Okay, let me write so also r1 equals to 4 sm, r2 equals to 3 centimeters. And of course, conversion to meters must be done. Okay, so now finally principle of superposition. V at this point will be V1 plus V2 plus V3. And we derive the formula for the electric potential created by the point charge. KQ divided by R. So for the first charge, K, Q1 divided by R1 plus K. They're all positive, so Q2 divided by R2 and plus K times Q3 divided by R3. You know what, so it bugs me. I'm afraid that some of you again forget about conversion. So let me write it 4 times 10 to the power of minus 2 meters, 3 times 10 to the power of minus 2 meters. Okay, numbers I'm not going to plug. Okay, another question. I think you have the number labeled. Maybe. Okay, let me check. No, why you think so? This is the charge Q1. Over there maybe. R1, 4. Okay, this, yeah. Thank you, guys. You speak up, please, right? Because I cannot keep track of chat all the time, right? All right, so this will be, okay, now I, yeah, this is R2, and that is R3. R2, and this is R3. Okay, thank you. Yeah, as I said, no, I'm not going to plug numbers. You can do that easily. I will just write down the answer.